Hi, welcome to the Calculus 3 assignment practice series. And we are in the unit vector calculus. So this is our assignment number 9 about how to do the surface integrals. So I'm going to show you how to do a few problems and hopefully it will help you to finish the whole assignments here. Okay, so now let's go ahead and take a look at our assignment sheets here. Okay, so let's start here. So this is the one we have try to find the surface integrals here. The first two problems are pretty straightforward. So the problem provides you the parametric equations and how do you parameterize the surfaces here. And then I'm going to do a problem number 10 here. And problem number 10 here is very similar, like one of the example we did in the lecture series. And so let's take a look here, all right? So these ones here, they give you the function of the planes here. So now we want to take a look at how do we do the parameterizations here. All right, so here, so these ones here, so we have a 2x plus 2y plus z equal to 4. So first, I think we can change that to say the z is equal to the 4 minus 2x minus 2y. So I think the easy way we can do the parameterizations will be, let's say the x equal to u and the y equal to v. And then my z will be 4 minus 2u minus 2v. That's right. Okay, so now my parameterizations, the vector uv will just be equal to the uv and the 4 minus 2u minus 2v's here. Okay, so now after we do that, let's take a look at what is the regions, what is the region D we are looking at here. Okay, so for the X, Y, Z here, right? So in here we have a 2x plus 2y plus z equal to 4. So if x and y equal to 0, z equal to 4 here, and if the y and z equal to 0, x equal to 2, and x and z equal to 0, y equal to 2 here, right? So this will be the surface here. So this surface, these triangles here, so this is the surface we're going to take our integrations here. Okay, because, right, so because we say x equal to u, y equal to v, so this bottom, these triangles here, that's what is going to be our region D here. So if you do like this, okay, so now if I change it to the UVs here, so here, let's do here. So this is U and the V's, right? So it's 1 and 2 and 2, right? So this will be 2 and 2 here, right? So 2 and 2, and we have, this is my region what? This is my region D here, correct? Okay, so because this is my region D, so I know this one's here. I can write this one. This is will be V is equal to the 2 minus u's, right? So let's lines here is 2 minus u. So when we integrate along this yellow triangle, then we know how to put the boundaries here. Okay, so right now we got everything, almost everything we need. So the next things here, so we can say the u is from what? Z to 2, 0 to 2, right? And what is my v's here? V will be from 0 to what? 2 minus u's, right? So like we said before, this region, this boundary is the most important part. So we take the integration, we know how to do that. Okay, so now we can do the same thing. So RU, UV is take the partial for U. So this is 1, 0, negative 2, right? And then the RVs here is to take the partial for V, so it's 0, 1, negative 2. Okay, so now we do the RU cross RV. So this one is pretty easy to do. So the RU plus RV will be 2I plus 2J plus K. All right, then we want to find the magnitude of the cross here. So it will be 2 to the square plus 2 to the square plus 1. This is a good one. So it's 3 here. Okay, so now let's try to write this surface integration s xz ds. So we say we can write it into the UV integrations here. X is what? X is u, so it's u. Z is what? 4 minus 2u minus 2v's, right? Then we need to times the here, so it's times 3. And after that, then you can do du dv or dv du. So in here we say because the v is bounded, so we take the dv first, then e du. So v will be from 0 to 2 minus mu, and u is from 0 to 2 here. And then this one here is now which transfer this surface integration to a typical two variables integration we learn in the calculus 2, and we know how to do that. So if you try to, so after you get this, and then I think after you integrate and substitute the value, and here, okay, so here, so we'll get these answers here is 4 here. Okay. So this ones here is just like if they give you a XYZ plans here, how do you do that? And we did that. So this is kind of like just a brief review about what we have. Okay, so the next ones here, and next ones here, we want to take a look the vector field when we try to do the, the surface integration. So for the vector field, so for this ones here, so the RUVs, right? So they already tell us how do we do the parametrizations. So here, that means this is my X value, this is my Y value, this is my Z values here, all right? Okay, so now let's do the same ways here. We need to do what? We need to have a R partial use, right? So partial use here will be cosine V and the sine V and the what? Zeros here, right? Then we have a partial V. What is the partial V's here? Take the derivative of V. So this is U sine V and the U cosine V and the 1. All right, and then we do the same thing. So you do the RU cross RV. So you put it into the determinant matrix, just like we did. So you can find the cross is will be sine V, negative cosine V, and the U's here. All right. So now I need to find what is my f of x, y, z here. Okay, so the first thing here, okay, so this one's here, the I component is Z. So what I have here, I have V's, right? So the J components is Y. So what I have here is U sine V. And what is X here? X is U cosine V. Correct? Okay, so now my integration over this surface of the, okay, the DS is here will just be equal to, that I do the cross product, I do the dot product. So this is V, U sine V, U cosine V, right? Cosine V, and the dot sine V, negative cosine V, and the U's here, right? And then we need to take a look at du dv. So here it doesn't matter. So we said dv du. Okay, if you do dv, v is from where to where? 0 to pi, u is from 0 to 1. Okay, so if you simplify a little bit, and then this integration will be 0, 1, 0 pi. So you do the dot product, right? So the first times first, second times second, third times third, and add it. So you will have this one here is V sine V and the minus U sine V cosine V and the plus U square cosine V. right? Then you do dv du. So we change this vector field, the surface integration to what? To the also to this two variable simple integrations here. So now you can do your regular integration. It's no special skills. It's kind of required. So now in here, you will see this is what? This will be the pies here. Okay. All right. So then the next things here I'm going to do is problem number 23 is here. And so for this ones here, we said f of x, y, z is vector fields here. S is a part of the paraboloid is z equal to 4 minus x squared minus y. That lies above the square and upward orientations here. So here we need to be careful. So this is what we say is the upward orientation. So that's what is our surface integration. If you see here is downward, then you just like the line integral. If you take the positive orientation or negative orientation, then you need to have a negative sign in front. All right. So because in here z is 4 minus x squared minus y squared, this one's here, instead of doing parametrization, I can use the problem number 2, the method number 2. So this is p, this is q, this is r's, right? Then my gxy is equal to 4 minus x squared minus y squared. Then we know the gx is negative 2x, gy is equal to negative 2y. So probably it will be pretty easy, right? Okay, so now I say, okay, this is the integration. So in the surface, this is f of the ds here, right? Okay, so you still remember the formulas here. We have rho p, then rho g, rho x, rho minus q, rho g, rho y plus r's, right? Okay, so now let's see here. Then you change everything to x, y's here. Okay, let's take a look at negative p. So it's negative xy and times gx. So times what? Times negative 2x minus q. So it's minus yz times rho g rho y. So it's times negative 2y. And then plus the z-axis, right? So here's z-axis. And now you want to do dx dy or dy dx, it doesn't matter. Okay, so here, the only things here, we need to be careful here because I only have x and y. So I have here, I have a z here. So I need to replace the z's here, right? So if you do dx dy, so this is 0, 1, 0, 1 here. This is the formula. This is the method 2 formulas here, right? So you will say this is 0, 1, this is 0, 1. So negative, negative, so it's 2x squared y. So for here, this is plus 2y squared. Like I said, you only integrate, right? So in here, right, you integrate to the dx dy's, right? Okay, so that's why you need to replace z. So what is z here? Z is 4 minus x squared minus y squared. Then plus, this is x, and then replace z also. It's 4 minus x squared minus y squared dx dy here. So then you can combine and simplify that, and then it will become just very simple two variable x, y variables here. And then here, the final answer, it will be 713 and 180 here. Like I said, the reason why I want to do these problems here, because these things here, because we say, hey, this one here is the upward orientations, right? So it's kind of like similar like the line integral, the positive orientation. So if this is downward, then you need to put a negative sign in front of it. All right. So that's why if you take a look at the next problems here, right? So, you know, the next problem. So when you do these problems, you need to be careful because then this problem says downward, right? So if downward, just like integration and line integrals here, don't forget to put what? To put a negative signs there. All right. So that's what it's about. And so I think after you get familiar with it, and then you really figure, the service integration is not really too bad, right? And as long as you know, of course, how to for a given service, how to find a parametric equation about that. That is the tough ones here, right? So sometimes it's very difficult to find. All right, that's it. And hope the 3 problems I did here and will help you to finish these assignments. And so you can practice the other problems are very similar and follow the same methodologies here. All right, that's it. And so I guess we'll talk to you in our next topics here. Okay, bye.